Hello, here is a standard deviation question I've been asked to go through. So let's just dive straight in. Somebody is investigating variation in air temperature and used the large data set. Selected the first value by generating a random number and then selected every fourth value after that. So it'd be tempting to say this is random sampling, but if it was proper random sampling, I mean, it's got the word random in it, but that only generates the first number, and then she's sort of sequential or systematic, you might say, by picking every fourth value. If it was proper random, it would be generating 15 random numbers or possibly more. If she makes the same number twice, then you'd have to do another one. But the fact that wherever she starts from then takes every fourth value is systematic sampling. So that one was easy for a mark. Part B, calculate the standard deviation. Well, you should know that the standard deviation, sigma, is the square root of the variance. And the variance, now we're given it in sigma x squared and sigma x and n. So rather than the x minus x bar in a bracket squared, we're going to use the other form of the formula, which you really ought to know, which is sigma x squared over n. Notice how the x squared is inside the sigma, minus sigma x over n, and this squared is very much not inside the sigma. In fact, it's outside the whole bracket. So we're going to use that, and we have these values. Sigma x squared is this value, which goes in here. The n value 15 obviously goes in there. And then in this bracket, we use 339 spot 6 and 15 again. Put it all in the calculator in one big go, and you should get the right answer. Okay, I'll leave you to do that one. I assume you can pop that into the calculator. Then it says an outlier is defined as a data value which is more than 2 standard deviations from the mean. Show that the temperature recorded is an outlier. Drat. So I will need to actually work out what the standard deviation is. So I'll need a calculator because I need to know it for part C. So square root of fraction, and we need to put in this squared number. So that's 7994.8 over 15 minus, we'll have a bracket there and another fraction, and move my calculator out of the way, 339.6 also over 15, close the bracket and square it, and the answer comes out as 4.52. Well, let's do let's do 3 significant figures. Assume that is acceptable. So 4.52. And now a data value which is more than 2 standard deviations from the mean. Okay, so we need to know what the mean is. Okay, so the mean is this thing in the bracket, sigma x over n. Okay, x bar is the total amount of x divided by how many. So let's just do that. Hang on, bring in the calculator again. So we've got 399.6. No, we haven't. Got 339.6. Better. Divided by 15, and we've got a mean of 22.64. So 22.64, that's our mean, and we're allowed to be 2 standard deviations from the mean, above and below. Obviously, our 9.7 is below, so we're going to do our 22.64, take away 2 lots of 4.52, which is our standard deviation. And if we work that out, then the limit for what is or is not an outlier is 13.6. So yes, indeed, 9.7 has to be an outlier because it's outside the limit that we would accept values to be. So it is an outlier, that's what the limit is, and it's outside that limit. Clean the data. Well, cleaning the data simply means to modify it so that we're just using the values that are not outliers. So we can't have the outlier present in the data. We want to work out the mean standard deviation again, considering that we've lost this 9.7. So if we do that, let me just come up here and get rid of some of these things. If we get rid of that, then there's only going to be 14 values of n now. The sigma x is going to be 9.7 smaller, so whatever that is, you'll have to work that out for that one. And for this one, you'll have to take away 9.7 squared, because this is the sum of the x squared values. So 9.7 was squared and added in, so we need to square it and take it off and get those two new values. And then we just do the same as we did before, recalculate the mean, and we'll do that by just doing this new value over 14 and recalculate the standard deviation. We'll just use the same formula as we had before, sigma x squared over n minus sigma x over n squared, but using these two new values and the 14. Okay, that I will leave you to work out for yourself. And then it says, from your knowledge of the large data set, explain why the sampling process might not generate a sample size of 15. Now, if you actually looked at the large data set, then I think the answer that the mark scheme for this question actually gives is a bit silly. It's a generic answer, I think. The answer that it gives is that there might be numbers missing from the data. She's just assuming that that there will be, this for the 2 months they've got a piece of data every single day. If there were some days that there was data missing and that happened to be one that she landed on with her every 4th, then she might not get a full sample size. But if you, from your knowledge of the large data set, well, I don't remember seeing any data missing when I I didn't look at everything, to be fair. So I think that's an odd question and answer combo that they've put in. So if that one's not so clear, I think we'll put that down to an odd question. If you have any more queries, if there's anything I got wrong or you think needs a bit more explanation, then either let me know in the comments, or if you have the capacity, then you can send me an email and I will respond to that. Thank you very much. Ta-ra for now.